Today we're doing solving equations by factoring, and honestly, this is nothing new really. It's just kind of an extension of what we've already been doing. So we're going to start by making sure one side equals 0. Anytime you're factoring with an equation, so factoring with an equal sign, you need to have one side equal to 0 before you start factoring. So but then basically ignore the equals 0. We're really just going to focus on factoring this thing right here. First thing you always want to check. So first thing is get one side to equal 0. The second thing is to check GCF, greatest common factor. And then the third step is to just factor however we can factor for that particular problem. This one, check GCF. They both have x in common. X squared divided by x is x. 2x divided by x is 2. Okay. Off to the side, I have a little game for you. This one is fully factored. So for those of you who are not colorblind, I have a pink card right here. And I have a blue card right here. These cards have numbers behind them. And I will tell you that we are going to take these two numbers and multiply them together, and the result is going to be 0. So what has to be true about either the pink card or the blue card if when you multiply them together, you end up with 0? Either the pink card has to be 0 or the blue card has to be 0. So at this step to solve, x is the pink card and x plus 2 is the blue card. So if the pink card is 0, then x equals 0. If the blue card is 0, then x plus 2 has to equal 0. We can solve that equation and get x equals -2. So our two solutions are 0 and -2. All right, example B, again, check to make sure you have equals 0, then factor the left side, or factor the side that isn't 0. This particular one is a difference of two squares, so it factors into x plus 5, x minus 5. Then we do the guess the number behind the card trick. This time x plus 5 is the pink card. If the pink card has to be 0, what number plus 5 is 0? -5. The blue card is x minus 5. If the blue card equals 0, what number minus 5 is 0? +5. So our two solutions are 5 and -5. Or you could also write that as plus minus 5 because it's +5 or -5. Example C, make sure it's equals 0. Then we factor the left side. We're looking for two numbers that multiply to give us -6 and add up to -1. That would be 2 and -3. So the factored form is x plus 2, x minus 3 equals 0. If x plus 2 has to equal 0, one of our solutions is -2. If x minus 3 has to equal 0, one of our solutions is x equals 3. All right, so we're not always going to have, I'm just going to check quick on how many examples we have. We're not always going to have perfect problems that already equal 0. So in these examples, we need to do something to get one side equal to 0 first. So anytime that you see x squared and x in the same equation, you want to get one side equal to 0 so that you can figure out if you need to factor or whatever. So I'm going to subtract 6x on both sides. X squared minus 8x plus 16 equals 0. We need to factor this, so we're looking for two numbers that multiply to give us 16 and add up to -8. That would be -4 and -4. Do you see how x minus 4 and x minus 4 are exactly the same? That means it's x minus 4 squared. But as far as solving it, this means that x minus 4 is going to have to be 0, because that's the only way. These parentheses have to be 0, because 0 squared would then give you 0. So our solution is positive 4. There's only one solution for that one. Okay, example B gives us a really, it's a really good example, because you really don't want negative x squared. You want your x squared term to be positive. It's just easier for factoring if your x squared term is positive. So I will add x squared to both sides. Make sure it's in the proper order with x squared first, and then your x term, and then your number. We're looking for two numbers that multiply to give us 36 and add up to negative 13. 3 times 12, no, 4 times, 4 and 9. Negative 4 and negative 9. So x minus 4, x minus 9. So what are the solutions? Solutions are positive 4, because 4 minus 4 would give us 0. And positive 9, because 9 minus 9 would give us 0. Okay, example C, first step, get 0 on one side. So we have 2x squared plus 5x minus 12 equals 0. Okay, there's a number in front of the x squared, so check, is there a greatest common factor? No, there's not. This means that we need to multiply the 2 and the negative 12 together. So we are looking for two numbers that multiply to give us negative 24. Those same numbers have to add up to 5. So numbers that multiply to give us 24. 1 times 24, 2 times 12, 3 times 8, 4 times 6, negative 3, and 8. Okay, I prefer factoring by guess and check, and I really wish that you all would prefer factor by guess and check. So I'm going to do that first, because I want you guys to see how it's really not that much work. The only way to get 2x squared is to have 2x times x. So that's a definite. One of them is going to be 2x, the other one's going to be x. 2x times something is going to give us one of these two numbers. Well, it's not going to give us negative 3, so it's going to give us 8. That means 2x times something has to give us 8x. That means this must be a plus 4. Then x times something has to give us the other one. So that has to give us negative 3x. That must be a negative 3. So our factored form is 2x minus 3x plus 4. If you really prefer factor by grouping, you would have to do 2x squared minus 3x plus 8x minus 12, split it. Factor out the GCF here. Factor out the GCF here. Somehow not make any mistakes doing that whole process to get the factored form. All right. How do we solve this? If 2x minus 3 has to equal 0, set that up as an equation and then solve it. Add 3 to both sides, divide both sides by 2. One of our solutions is positive 3/2. The other solution is a little bit easier. What number plus 4 is 0? Negative 4. So our two solutions are positive 3/2 and negative 4. Example 3. Oh my gosh, how many of these do we have? Okay. You always want to start by checking for a greatest common factor. I see x cubed, so there's probably a greatest common factor. They all have an x in common. Okay, I want you to pause the video and factor this part and then see if you can figure out how to solve this. Play the video once you're done so you can check, and I'll give you some more instruction then. Okay, so I factored this, and we've got x minus 2, x minus 5. We have this x in front that we factored out originally, and the whole thing is still equals 0. So now instead of having a pink card and a blue card, we have a pink card, a blue card, and a purple card. We have 3 cards. So if this part is 0, our solution is 0. If the second set of parentheses equals 0, our solution is 2. If the third set of parentheses equals 0, our solution is 5. So this one has 3 solutions. Handy hint, your largest exponent is going to tell you the possible number of solutions you're going to have. If it's x to the third, you have the possibility of having up to 3 solutions. So having 3 solutions shouldn't surprise you when it's x to the third. In example B, I would like you, well, yeah, those are all divisible by 3. I would like you to get 0 on one side, factor out the GCF, and see if you can factor this one just like we did in example A. So pause the video, try example B on your own, even if it's the only example today that you write down in your notes, and then play the video to check your work. Okay, one little thing before you start. I know some of you like to be strategically lazy and do the least amount of work possible, but subtracting 3x cubed from both sides is going to make that first term negative, and that's not going to work in your favor. So I would instead subtract everything from the right side over to the left side. That'll just make your life easier. Okay, now go. All right, this one does tend to catch a few of you because you see 6 and 5, so you think it's going to be 2 and 3. It's 1 and negative 6. If 3x had to equal 0, 3 times what is 0? 0. If x plus 1 had to equal 0, x would be negative 1. And if x minus 6 had to equal 0, x would be positive 6. Our solutions are 0, negative 1, and 6. I feel like on the test I'm probably going to write a question that says factor and solve, select all that apply, or 3 blanks, so we have to write 3 different solutions in. So this is likely going to be very similar to a problem, at least one on the test. Our last example has 4 terms. When there's 4 terms, what do? We factor by grouping. But first, do you see how all of the terms have an x? So my first step will be to factor out an x. Then we're going to factor by grouping. So really what we're doing is we're factoring x cubed plus x squared minus 4x minus 4. These 2 terms have x squared in common. These 2 terms have negative 4 in common. So we have x squared minus 4 times x plus 1. Are we done? I see x squared minus. That means we're not done. That factors into x plus 2, x minus 2, and we have that x plus 1. So now taking that back over here, we've got x plus 2, x minus 2, x plus 1 equals 0. This first part gives us the solution x equals 0. The next part gives us the solution x equals negative 2. This one gives us x equals positive 2. And this one gives us x equals negative 1. 4 solutions. But what did we start with? We started with x to the 4th, which means the potential for 4 solutions. All right, your assignment is in Schoology, 6.5 book assignment. Make sure you join the live chat if you're having any questions. Seriously, if you're having any questions about factoring, do not let factoring be the thing that gets you. I will help you with factoring. Get on the live chat and I will help you, make you feel like factoring is fun, right? We love factoring. Say it again, we love factoring.